This is AP, AB, and BC Calculus. We're doing Unit 5, Section 6, which is determining concavity of functions over their domains. So let's talk about what concavity is first. So we've already seen that we can use the first derivative of a function to determine the intervals on which the function is increasing or decreasing, right? So if f prime is less than 0, we have a function f that is decreasing, right, like this. If f prime is greater than 0, we have a function f that is increasing. And if f prime is 0 or does not exist, we have a critical number, right? We can also we can use the second derivative of a function in the same basic way to determine the concavity of a function. So if f double prime is less than 0, then the function is concave down, meaning it opens downward or it cups downward. So this is what concave down looks like. It can look like anything like this, essentially, right? That's concave down, cupping downward, right? If f double prime is greater than 0, then f is concave up. And so concave up looks kind of like this, right? So this is concave up. It's cupping upward, right? So it bends upward, okay? So if f double prime does not exist or f double prime is 0, we have a key point. Now that's a Hoganism because weirdly there's no term in math for this. I mean, there is a term. It is technically a critical number for f prime, right? Because it's when the derivative of f prime is 0, it doesn't exist. But we're going to call it a key point. And then points where concavity of f of x changes from up to down or down to up, meaning where f double prime of x is 0 or does not exist and f double prime changes sign, are called points of inflection or inflection points. So we're going to do some pictures of concavity to talk about what it looks like. So here's examples of concave down, right? And here's an example of concave up. Now, one way to picture this is that if something is concave down, see how the tangent lines of the curve sit above? So if it's concave down, the tangent line sits above the curve. And if it's concave up, the tangent line sits below the curve. So another way to picture it is that if something's concave down, then if you connect 2 points on the curve, then the line connecting the secant line, essentially, so this is a secant line, right, between 2 points on the curve, will be under the curve. And if something's concave up, the secant line would be above the curve. So that's another way to think about it. So here's a couple more images of concave down and concave up. I always kind of picture it as if something's concave up, it would hold water, right? Although you could argue that, like in this case here, it wouldn't hold any water, but it like catches the water as opposed to the water running off the top. So let's walk through. So we're going to find the x-coordinates of all points of inflection of f of x. So when you read this, right, your brain needs to read this phrase and think a couple things, okay? So your brain needs to think f double prime is 0 or does not exist, and this is important, f double prime changes sign. So that's what we're looking for. We're looking for, that's what this phrase means. When you see that phrase and you think, what do I have to do mathematically? The answer is you need f double prime. You find when it is 0 or does not exist, and you find when it, meaning f double prime, changes sign. So I need f prime first, which is going to be 4x to the third plus 6x squared plus 3. And then I need my f double prime, which is going to be 12x squared plus 12x. So this is what I need, right? To find those key points, right? So those key numbers are those key points. I need when f double prime is 0, which is going to be, I'm going to yank out a 12x and be left with x plus 1 here. So that's going to be when 12x is 0, which is just x equals 0, right? Or when x plus 1 is 0, which is going to be at x is negative 1. Or I need when f double prime does not exist, but because this is a polynomial, it's not an issue. And there are no endpoints in this. I'm given just the entire domain of the function. So I'm going to make a sign chart for f double prime. So remember, if you don't have endpoints, you need infinities, right? So we've done a lot with endpoints lately. Also make sure that your x values go in ascending order, right? This is essentially a number line. So 12x is the first factor, and x plus 1 is the second, right? This is an f double prime sign chart, which is important. You need to make sure it's clear that it's an f double prime sign chart, right? And I'm going to use that f double prime to find out things about f. So 12x is a line with a positive slope, so if it's 0 at 0, it is negative before 0 and positive after. X plus 1 is also a line with a positive slope, so it's 0 at negative 1, it's negative before negative 1, and then positive after. So my f double prime is going to be positive, negative, positive, which means my f is concave up, concave down, concave up. So when I'm asked for the points of inflection, it's going to be both of these spots because you can see that the concavity changes. I was only asked for the x-coordinates, so there are points of inflection at x equals negative 1 and 0. But again, you have to check that both of them are points of inflection because sometimes the curve's not going to change concavity. Ignore that. Sorry, a thing just popped up randomly. So sometimes the curve's not going to change its concavity at those points. All right, so go ahead and give P1 a try. So you can do the same thing. Again, when you read this, I need your brain, right? And if you need to make a note card for this, I would suggest it. Your brain needs to say, cool, I'm looking for two things. I want when f double prime is 0 or does not exist. And I need when f double prime changes sign. If f double prime doesn't change sign, it's not a point of inflection. Okay, so f prime of x is going to be a 5x to the 4th minus 20x cubed plus 2. F double prime of x is going to be a 20x to the 3rd minus 60x squared, which means that when I factor out a 20x squared, right, I'm left with an x minus 3. Cool. So I need those key points, right? So those key values are going to be when f double prime is 0. Well, that's going to be when 20x squared is 0, which is going to be at x is 0. But that's going to be a double root. And we'll talk about the significance of that in a second. But essentially, you have x squared equals 0, which means x is 0. So it's a double root, right? And that's going to matter. Or when x minus 3 is 0, which is going to be at x equals 3. There are no places where f double prime does not exist because it doesn't have a denominator, and there are no n's in this problem. So all that needs to go on my sign chart is negative infinity, 0, 3, and infinity, right? So my factors are a 20x squared, which we'll talk about in a sec, and an x minus 3. It is an f double prime sign chart, and that's going to give me the concavity of f, right? So let's start with the x minus 3. It's a line with a positive slope. It is 0 at 3, which means it'll be negative before it crosses that 3 and positive after. But 20x squared is actually a parabola that just touches the axis but doesn't cross. 20x squared is going to be positive everywhere except at x equals 0. So what that means is that my f double prime is going to be negative, still negative, and then positive. So concave down, concave down, concave up. Well, that means that the only point of inflection is at x equals 3, not 0, right? Because, so one of the things you'll notice is as you do a lot of these problems, if there is a double root, the sign of something doesn't change. So in fact, not just a double root, but an even root. If this had been x to the 100, 100 is an even power, the sign wouldn't change. So if you have a double root or a fourth root, anything that's an even root, your sign's not going to change. All right, so at the given x value, is f of x positive, negative, 0? Is f of x increasing, decreasing, or neither? And is f of x concave down, concave up, or neither? So what all of these questions are asking you is they're asking you the sign, right? So A is asking you, so the sign of dot, 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 f of 0. B is asking you the sign of f prime of 0. And C is asking you the sign of f double prime of 0. So if you know that, you just need to find the three functions and then just evaluate them at 0. That's what's being asked, right? So that's the question that's hidden in here. Because positive, negative, or 0 would be the sign of f of 0. Increasing is if f prime of 0 is positive. Decreasing is f prime of 0 is negative. And neither is f prime of 0 is 0. Concave up would be f double prime of 0 is positive. Concave down would be f double prime of 0 is negative. And neither would be if f double prime of 0 were 0. So let's go ahead and differentiate. So you might as well do A first, right? So you can do A, right? I can do A by just plugging into f of 0 into f with 0. So I get 0 times e to the 0 plus 2. That's a 2, which is greater than 0, so positive. So the answer to A is positive. Okay. For B, so I'm going to have to differentiate for B and C, right? So for B, this is a product rule, right? U and V. So U dv is going to be a negative e to the negative x because of the chain rule, plus v, which will be e to the negative x du, which is a 1. So you can clean this up if you want. It's entirely up to you. I'm going to yank out a negative e to the negative x and be left with an x minus 1, right? That means that for b, I'm going to plug in f prime of 0 and get this as a negative e to the 0 times a negative 1, which seems to be a positive 1, which is greater than 0. So my answer is increasing, right? If f prime is positive, then f is increasing, right? So increasing, right? And then for C, I need f double prime of x, right? I'm going to go ahead and use, it's up to you. You can either use the product rule here on this version, or you can use the original version, right? It's up to you. I'm going to use the product rule here. I'm going to call this my u, and I'm going to call this my v. So my f double prime, I'm going to do u dv plus v, and then du is going to be a negative times the negative e to the negative x, so that'll be a positive e to the negative x, right? And then I need f double prime of 0. Well, that's going to be negative 1 times 1 plus a negative 1 times a 1, which seems to be a negative 2, which is less than 0, so concave down. Right, so my justification is finding f double prime of 0 to be less than 0, is finding f prime of 0 to be greater than 0, so this is my answer to C, right? All right, now if you had a calculator, you can make your calculator differentiate at a point, but we're assuming here that this is a problem you'd be asked to do by hand. All right, so let's go ahead and try a P3, or a P2 rather. All right, so same idea. You're doing this at x equals pi, right? You're answering, is the function positive, negative, or 0, increasing, decreasing, or neither, concave up, concave down, or neither. And again, it's the same question just for different derivatives. So go ahead and do it without me if you want. I would point out that if I were doing this on a test, I would absolutely bust out A first, because you can do A without any calculus at all, right? You can find f of pi is equal to negative 5 plus pi times 1, because it would be cosine 2 pi. So this is less than 0, because remember, in your brain only, pi is darn close to a 3, right? So negative 5 plus 3 is definitely less than 0, so f is negative. Again, this is when you use that idea that pi is close to 3. You don't ever write that down, but you have to have an ability to estimate like a value, and to know that negative 5 is more negative than pi would be positive. Okay, so my f prime, I differentiate the negative 5 and it's gone, right? So then I get u dv, the derivative of cosine is going to be negative sine of 2x times the 2 for the chain rule. So I'm going to get negative 2 sine of 2x, right? Plus v, which is cosine of 2x, du, which is going to be a 1. So again, I don't see that there's a ton of point in cleaning this up just to plug in. You might want to clean it up in a second in order to find the second derivative, right? So for b, right, so I did a already. For b, I know that sine of 2 pi is going to be 0, so I don't even bother cleaning this thing up when I differentiate. Plus, this would be cosine of 2 pi times a 1. Well, that's just a 0 plus 1, which is a 1. That's greater than 0, so f is increasing, right? So my reasoning is that f prime of pi is greater than 0, so f is increasing, right? So f is increasing, right? So f is negative. That was my answer to A, right? F is negative. My answer to B is f is increasing. Now, I am probably going to want to clean up this first derivative to find the second derivative. So my f prime of x is a negative 2x sine of 2x, which is definitely going to be a product rule, plus a cosine of 2x. So here's my u, here's my v. I'm going to need a product rule. So my f double prime of x is going to be u. Derivative sine is going to be regular cosine, but then I need to multiply by 2 for the chain rule. So 2 cosine 2x, right? Plus v, which is sine of 2x, du, which will be a negative 2, right? And then the derivative of cosine 2x, right, will be a negative 2 sine of 2x, right? Because it would be a negative sine of 2x times the 2, right? Now, I'm going to argue that, yet again, there's not a whole lot of point in cleaning this up, because anything that has a sine of 2 pi is going to be 0 anyway. So this is going to be a negative 2 pi times a 2 times a 1, plus a bunch of 0, because the sine of 2 pi is 0, plus a bunch more 0. So I'm going to get that this is a negative 4 pi, which is definitely less than 0. So since f double prime of pi is less than 0, f is concave down. Right? And again, this is not asking all the time. This is saying at a very specific moment, right? Very specific moment, tell me about f. Okay, now you'll likely see this as multiple choice, where they say, here are 5 things, which of the following are false, right? And they might say, so if I were writing this problem as multiple choice, I would say something like, they would say, which of the following is false at x equals pi? And they would say, f of x is negative, f of x is increasing. And then they'd say something like f of x is concave up, and you'd say, oh, that's the one that's false because I know f of x is concave down, right? And then answer D or answer E might be something like, these answers can't be determined by the information given, but that's almost never the answer. The answer cannot be determined from the information given is pretty much always a trap. Okay, so when we get to example 3, we're given one of these tables that a lot of us find really intimidating when we flip to them as a problem. Remember that a table is actually a gift because it means they've made the sign chart for you. So we're given this sign chart, right, for f double prime. How nice of them, right? Here's my sign chart for f double prime, and we're asked to describe the point of inflection of f, okay? The only tricky part about this problem is this thing at the top, which says f is a function defined from -2 to 2, but your sign chart is only from 0 to 2, so you have to be heads up about that. And they tell us that f of negative x equals f of x. Well, this is the definition, right? This is the definition of an even function. Meaning, so examples of even functions are things like x squared, right? Or something like the absolute value of x, right? Things that are symmetric about the y-axis, right? So this means symmetric about the y-axis. So you're probably, if you're not careful, right, you could miss one of the points of inflection in this problem. So let's look at what we're talking about here. So here's 0 and 1 and 2, right? And that's the end point of the problem. So I know that from 0 to 1, so we know f double prime is negative and then positive, meaning that what's happening to f is concave down and then concave up, right? The question is what's happening on the other side of this thing, right? Well, think about it this way. If we draw kind of a sample of concave down and then concave up, right? Remember that what it means to be even is that you fold over, you would fold over the y-axis, right? You're symmetric over the y-axis. So let's say that this is a sample of what this looks like. On the other side, if I fold it, it would also be concave down here, right? So concave down, and then concave up, because again, I have to be able to fold across the y-axis, right? This is the y-axis right here where x is 0. So if we can figure that out visually, and again, this isn't the exact graph. I don't know what the exact graph looks like, but it follows the guidelines that I was given, right? So knowing that there is a point of inflection at 1, right, because I change, my concavity changes from down to up, right? And there's also a point of inflection here at -1, because again, the concavity changes from up to down. So the points of inflection for this particular graph are at -1 and 1. Right? So again, what makes this problem hard is not that it's a table, but it's this trick line about it being an even function. And I did that on purpose. If they had said that f was only defined from 0 to 2, it would be a pretty straightforward problem. All right, moving on. P3, same idea. You see this table, right? Your function is defined from -2 to 2, but see the table only goes 0 to 2. And then you are given this fact, which is the same as saying f of x is odd, right? So f of x is odd. Now, what it means to be an odd function, right? So a classic example of an odd function is x cubed. So as an example, x cubed. So that's meant to be a colon. So x cubed, which would look like this, right? X cubed. So if we look at this example of x cubed, on this side we have concave up, right? So concave up. And here we have concave down. And this thing is rotationally symmetric about the origin. So knowing that, we can kind of figure out what would be happening on the other side. So here's 0 and 1 and 2. And remember, 2 is the end of this problem. And let's figure out what the other side's going to look like. All right, so my f double prime from 0 to 1 is negative. And from 1 to 2 is also negative. So there's no point of inflection there. So what's happening is I have a graph that is cupping down essentially this entire time. And it's negative in the middle, too. See, there's a negative sign there. So it's cupping down the entire time. Well, if this thing's symmetric about the origin, then it must be cupping up on the other side, right? So here we've got positive and positive. So the only point of inflection, right? So that means my f is cupping up, cupping down. The only point of inflection in this graph is at x equals 0. But again, if you didn't notice the thing about the odd function, you would think there are no points of inflection because there's no sign change on this half of the chart. All right, moving on. So now we're going to ask that same question, positive, negative, 0, increasing, decreasing, neither, concave up, concave down, or neither, all about f of x at the point where x equals 0. So looking at x equals 0, right? So at x equals 0 falls in the middle of this spot in the table, right? So x equals 0 is in the window from -1 to 1. So is f of x positive, negative, or 0? Well, f of x is definitely positive, right? So f of x is greater than 0, so f of x is positive. That's just the definition of what it means to be positive. Is f of x increasing, decreasing, or neither? Well, f prime of x is negative, so f prime of x is less than 0, so f is decreasing, right? And then for the last one, f double prime is positive, so f is concave up, right? F double prime of x is greater than 0, so f is concave up. And you would write it as a full sentence if you weren't cramming this in. So when I say, so this problem, they handed you all the work that we've done in other examples that you didn't have to differentiate, you didn't have to do anything, you were just asked about a very specific point, right? So your job, sorry, I take that back. Look, I did a silly thing. My justification should have zeros in there, my bad. So remember, all of these values should say at 0 because I'm finding at x equals 0. So my bad, fixing that real quick. So that's a common mistake, right? So we need to say that we're talking about f prime specifically at 0 and f double prime specifically at 0. So my bad, there we go. But your job is to justify giving, so you're taking what you're given, right? You were given f prime and f double prime. Your job is to take those things that you're given, f prime of 0 is negative, f double prime of 0 is positive, and then use that to justify your answer, right? That's what they mean when they say justify the answer, because here, there is no heavy lifting of actually differentiating. You don't have to differentiate, you don't have to plug in a value, you are given the values. Here, it is just a pure question about whether you understand what those values mean. All right, moving on. So remember, again, be careful with your notation. Don't make the mistake I made last time. So we are looking at x equals 2. Notice that x equals 2 falls in this window, right? So that's what you're going to use. So answer A, f of 0 is less than 0 because it says it's negative, right? So f is negative, right? That's it, right? For B, f prime of 0, remember, don't say f prime of x is greater than 0, so f is increasing, right? And for C, f double prime of 0 is greater than 0, so f is concave up. Again, what you're doing is you're using the information you're given, which is f and f prime and f double prime, all evaluated. Oh, sorry, not 0, 2's. People, my brain. 2, 2, 2. Come on, brain. See, it's at x equals 2. Cut me a break. All right, cool. So I know it seems dumb, and I know I could go back and delete this video and redo it where I don't make that mistake, but it's actually more valuable that you see me do that, because boy, are you going to be mad if you do that on a test or on the AP. So please, please, please be cautious. Don't do those things, right? And if you make that mistake, go back and fix it, right? These were all 2's. Okay, cool. Moving on. So on what intervals is f of x concave up? Cool. So your brain should take this information and translate it to f double prime of x is greater than 0. That's what you need, right? You need f double prime of x to be greater than 0. So your job is to now differentiate twice, and then from that function that has been differentiated twice, make a sign chart and figure out when f double prime is greater than 0. So I'm going to rewrite my f of x as a 3 times this x squared plus 1 to the negative first. I could do this as a quotient rule with the high and the low. I could do that, right? So I could do a quotient, or because the numerator is just a number, right? The numerator is just a number, I could do the chain rule, and that's what I'm going to do. So I pick this, you do what you want. I'm going to argue the chain rule is easier, especially because all I really care about finding, right? All I really care about finding is f double prime, and this makes f prime a lot faster. So I'm going to get negative 3 x squared plus 1 to the negative second times the derivative of the inside, which is a 2x. Now I'm going to use a quotient rule. The reason I'm going to use a quotient rule now is because now the high function is not just a constant, so it would be a product rule if I did it this way. I'm going to go ahead and use a quotient rule. So my f double prime of x, right, is going to be low d high minus high. D low is going to be a 2 x squared plus 1 to the first times a 2x. Super fun. We'll deal with it in a second. On the bottom, I'm going to have an x squared plus 1 quantity to the fourth because the whole thing's squared. Now, you might be thinking, oh my gosh, what have I done? This is horrible. But there's a not horrible GCF on the top in a second. So I'm going to go ahead and leave this as a negative 6 times this x squared plus 1 quantity squared. I'm going to leave that as is. When I clean this up, I'm just going to go ahead and make this a plus 6x. But then it's going to be times a 2 and a 2x, right? So that's going to be a plus 24x squared. right? Because 2 times 2 times 6 would be the 24, and there's an x times an x, and then I have this ugly thing here. Here's the reason I left that. I can yank out one of the x squared plus 1's from the top and cancel it. So if I yank out an x squared plus 1 from the top, I get negative 6 times the quantity x squared plus 1, which I can totally distribute, plus a 24x squared, all over, and then I'm going to cancel one of the x squared plus 1's. So instead of it being to the 4th, I'm going to cancel that when I factor it out and make it to the 3rd. So my f double prime of x is going to be, when I distribute this negative 6x, I'm going to get negative 6. I'm going to get negative 6x squared minus 6 plus a 24x squared. I'm going to get what seems to be an 18x squared minus 6, all over a thing that's never ever going to be negative, right? X squared plus 1 is positive for real numbers, which means the whole denominator is positive. It's never 0. My only possible points of inflection, so now when I go to find those key numbers, either f prime is 0, which is 18x squared minus 6 is 0, x squared is 1/3, right? X is plus or minus, and you can leave it as a root 1/3. You could make it a 1 over a root 3. You could even rationalize if you really want, but I would suggest this is totally legit and fine. Why would you do extra math, right? No reason to do more work. F prime does not exist. F double prime does not exist is never going to be an issue because x squared plus 1 is always positive, and there are no endpoints. So the only values I have to put on my sign chart, negative infinity. I'm going to leave this as a negative root of 1/3. There is no incentive on the planet to clean it up, right? And so then I'm looking at this thing, right? And then the denominator that we have already established is literally always positive, right? So I know that this is a smile that has 2 roots, meaning it is positive before it crosses, so positive, right? Then negative and then positive. So I'm just going to fill out my sign chart like that, and you could have picked numbers to plug in. It's not hard to pick a nice number that is not, you could pick 0 to plug in here, right? If you'd plugged in 0, you would have gotten a negative 6, and if you'd plugged in a negative 1 and a 1, you would get positive numbers out, and you'd get 18 minus 6 in both cases. So that means that my f double prime is positive, and then negative, and then positive, which means f is concave up, concave down, concave up, and my 2 points of inflection, I believe they only wanted x coordinates, but we should go back up and check. Oh, on what intervals are we concave up? We don't even want points of inflection. We just want that the f is concave up from negative infinity to negative root 1/3, and again from root 1/3 to infinity. So it is important to go back up and read the question. I know that it's a long scroll on these because I've been mathing for a considerable amount of time. All right, let's do a P5. So same idea. If I were you, I would rewrite this as a chain rule. You don't have to, but it's a lot easier. So I want where is f concave down. So remember, the first thing you should do is translate this to what it's asking, right? This is asking when is f double prime less than 0, right? That's what you're being asked. So once you know that, you can go ahead and differentiate. So my f prime of x is going to be a negative 5 x plus 3 to the negative 2nd times a 1. So this one I can actually keep using a chain rule because there's no product rule here. So my f double prime of x is going to be a 10 over x plus 3 to the 3rd, right? And that's it. So it is worth noting that this graph has a vertical asymptote at x equals negative 3, right? And that's something I have to pay attention to on my sign chart. So when I go to find those key numbers, right, f double prime is 0. Well, that's never going to happen because 10 is 0 is a lie. The top is never going to be 0. F double prime does not exist. Well, that's not going to exist when x plus 3 is 0, which is at x equals negative 3, which fits because it's a vertical asymptote. And there are no ends, right? There aren't any ends here. So when I make my sign chart, the only thing that goes on here is a negative 3, and I would go ahead and give yourself a heads up that it's a vertical asymptote because that can kind of inform what it looks like, right? So I have 10 as the first factor, which is just literally always a positive 10, and I have an x plus 3 to the 3rd. Remember that when things are to odd powers, they behave just like the line, right? If something's to an odd power, it's going to behave just like x plus 3 behaves in terms of signs. So it's going to be negative and then positive, which means my f double prime is going to be negative and then positive. So f is concave down and concave up. Now, if you pictured what this graph would look like at negative 3, right, here's negative 3, it's doing this, which really fits with concave down and concave up. So when I'm asked on what interval is the graph concave down, my answer is that this thing is concave down, right, so f is concave down, on the interval from -infinity to -3 parenthesis, and that's it. Now, for the record, if I asked you, this is not a point of inflection because it's not a point on the graph. It's not a point on f of x. It's a vertical asymptote. So to be a point of inflection, you have to be a point on the graph. And so you weren't asked that, but just to be clear, it is a thing. All right, let's do an E6 and a P6 and then call it a day. So this is the graph of f, just f. On what intervals is f prime, or are both f prime and f double prime negative? Okay, so remember, your job is to translate what this means. F prime of x less than 0 means that f of x is decreasing, right? And f double prime of x is less than 0 means that f of x is concave down. So your brain is saying, this is what I'm looking for. So let's look for windows where, so we're looking for where f is going downhill and also cupping downward, okay? So downhill, uphill, uphill, downhill, downhill, uphill, downhill, downhill, uphill. Great, okay. I can cross off any interval where things are not decreasing. So I can cross off these intervals, they're not right? I can cross off this interval, I can cross off this interval because they're all increasing. So that takes care of decreasing. I want where this graph is concave down. Well, here the graph is cupping up, so that's out, right? Here the graph is cupping down, so those two intervals work, right? Here the graph is cupping down, and here the graph is cupping up, so that interval's out. So it turns out that my answer, right, so my answer is this window from C to E and this window from F to G, right? So when they say justify your answer, they want you to explain this. They want you to explain that that's what you're looking for. So my answer is the window from C to E, so C, E, and again from F to G, right? So the graph is both decreasing and concave down. So you want to take what they ask and relate it to what you can see with your eyeballs. That's your justification, okay? All right, one last graph. Again, this is the graph of f. We are asked when are both f prime and f double prime positive. So your first job, when you talk about justifying your answer, your job is going to be to translate what they asked into what you can see with your eyeballs. F prime of x is greater than 0 means f of x is increasing, and f double prime of x greater than 0 means f of x is concave up, right? So what you're looking for is where this graph is going uphill and also cupping upward. So I'm not going to go through all of them. I'm just going to look at the contenders. So this is the only window where I see that the graph is going up, right? So I can just look at that section. I want it to be going up and cupping up. Well, that seems to be happening here and only here, because you'll see here it's cupping down. So the only answer, right, the only answer here is from 4 to 5, right? That's the only place where the graph is both increasing and concave up. So last little thing is not so much an example as it is just a quick slide. So note that f double prime of x is the derivative of f of x, meaning we can use f double prime of x to determine the intervals on which f prime, which is the slope of f of x, is increasing or decreasing. So if f of x is concave down, the slope of f of x, meaning f prime of x, is decreasing. If f of x is concave up, the slope of f of x, meaning f prime of x, is increasing. So one of the things to keep in mind is, although we often ask questions about f of x, sometimes we will be asking questions about f prime. And in those cases, you have to recognize that for f prime, f double prime is the first derivative, right? F double prime is the second derivative of f, but it is the first derivative of f prime. And that's it for Unit 5, Section 6.